We've already seen some examples of abductive reasoning, although I didn't identify it for you at the time. Remember, we talked about how the Greeks used rationalism to understand the shape of the earth. And I gave you a number of observations that they made to understand this, not just one. Remember that they argued, the Greeks, that if the earth is round, then ships will disappear from the bottom up. And their observations affirmed that consequent. Now, affirming the consequent, remember, gives you no real certainty. And so simply that single observation that ships disappear from the bottom up does not prove the idea that the earth is round. But they combined it with other observations. If the earth is round, the antecedent, then a consequent will be that different stars will be seen in different locations. And because the Greeks were great travelers around the Mediterranean, I don't know what a location is, but because the Greeks were great travelers, they affirmed this consequent that yes, different stars are seen in different locations. A third argument was that if the earth is round, then obelisks of the same size in different locations will cast different size shadows. And again, they affirm that consequent of the antecedent. And finally, if the earth is round, then Earth's shadow during a lunar eclipse will always look circular. And many observations showed that the Earth's shadow does look circular. So again, we have a series of 4 logically invalid arguments because they're all affirming the consequent. On their own, none of these arguments proves that the earth is round or gives you real reason to believe the earth is round. But put together, 4 different phenomena all point to the same antecedent that the earth is round, and so we are then justified in reasonably believing that the earth is round. Another example I gave you was Galileo supporting the Copernican system with his discovery of the telescope. He made a number of observations. The observations were all consequence of the way the universe is. The antecedent, the idea that the Earth is a planet orbiting the sun through space, does that antecedent lead to the observed consequence? So one of the observations he made was that the moon shows mountains like the earth. Well, this is part of a deductive argument. If the earth is a planet orbiting the sun through space rather than being something made of different elements from what's in space, then the moon should show mountains like the earth. And Galileo's telescope showed that yes, the moon does show mountains like the earth, and therefore you can conclude in an invalid way that the earth is a planet orbiting the sun through space. Again, because that's invalid on its own, it doesn't really prove anything. But let's use inductive reasoning for more phenomena. If the Earth is a planet orbiting the sun through space, then other planets should also have moons that follow them around. And when Galileo looked at Jupiter, he found the 4 Galilean moons of Jupiter following Jupiter around the same way the moon follows the Earth around. Second invalid argument, but combining it with the first invalid argument gives it some inductive strength. And then we add the third argument. If the Earth is a planet orbiting the sun through space, then Venus should show phases as it too orbits around the sun in space. And lo and behold, Galileo also affirmed that consequent with his telescope. So again, 3 logically invalid deductive arguments are combined in an inductive way to give strong reason to believe the antecedent that the Earth is a planet orbiting the sun through space using what we call abductive reasoning. Now, this is sometimes called the hypothetico-deductive method because we're taking an antecedent that we can call a hypothesis, and we're seeing if deductive arguments from that hypothesis actually match the consequence that we observe in space. And that's really at the heart of the scientific method, as we will see. The same thing happens in medical diagnosis. If the patient has fever, vomiting, diarrhea, RLQ pain, and abdominal rigidity, the antecedent, the hypothesis of appendicitis would explain all of those consequences. And again, in criminal law, the antecedent that this suspect is the killer is claimed to deductively fit into all of these consequences. And therefore, it provides an explanation for all those consequences. But there's still a problem here. And the problem is this. The hypothesis was actually developed from the observations in order to explain the observations. So of course, the hypothesis will explain all the known observations because it was made to do that. We saw that with the four-element theory. The Greeks kept adding elements, or starting with fire, then they added water to explain why adding water to fire actually makes the fire go out rather than making it bigger. Then they added air, they added earth, and they kept adding elements until they could explain all the known observations. So how can you argue that the fact that four-element theory explains all the known observations is actually proof that the four-element theory is true because it explains the known observations? Same thing we saw with the Ptolemaic system. The Ptolemaic system was meant to explain the observations. Remember the idea of how can we explain apparently non-circular, non-uniform motion using uniform circles. And what Ptolemy did was he added enough epicycles, he added the equant and the eccentric until that hypothesis of the Ptolemaic system fit all the known observations. Well, you can't then say that, well, look, the system fits all the known observations. That proves the system is correct because you built the system so that it would fit all the explanations. Something more is needed to get to the modern scientific method, and that's for the next video.